All right, guys, hey, we are shifting sine and cosine graphs left and right today. What I want to draw your attention to before you start copying all this madness down is, let's go back to Algebra 2. Do you remember when you learned parabolas, stuff that had x squared in it, and all of these different ways to move and stretch and shrink your parabola? So remember how if you have like an x squared equation like this, if it's negative, that means your u shape is upside down. The fraction in front made it fatter, or if it was a whole number, it was a skinnier U shape. This plus one actually meant left 1 unit because it was inside the parentheses, and this minus 2 hanging out here is down 2. That's exactly what we're doing with sine and cosine graphs today, is we are shifting, reflecting, shrinking, stretching, moving left, right, up, and down, and you're going to see a lot of similarities between that from Algebra 2 and what we're going to talk about today. So anyways, you can go ahead and start copying some stuff down. If I go too fast, go ahead and pause the video. But we have these two new things. A phase shift is moving your graph left or right. Okay, a vertical shift is exactly the way it sounds. It's moving your graph up or down. And there are different numbers and ways to manipulate your equations in order to do that. So if you look at this very first equation, I have my normal y equals sine of x graph. That's the graph that you have on the very first page of your packet. And what if I threw this minus pi over 3 inside the parentheses here? Just like the parabola equation, that actually means right pi over 3. So what you'll notice here is on this graph, all of these dots have been moved to the right pi over 3 units. And so that is what happened here, and that's because of this right pi over 3 situation. And notice how my graph doesn't start on 0 then. It actually started here at the right shift of pi over 3. Just make note about that, okay? Same thing with this equation. So the red dotted equation is cosine of x, and it has an amplitude of 3, which means that the humpiness is a unit of 3 and not just 1. And that's why it starts up here at 3, is because the amplitude is 3. But this plus pi over 4 inside the parentheses indicates a phase shift of left pi over 4. And so all of these x values have been moved to the left pi over 4 units. And so again, my starting point went from 0. It's no longer starting at 0. It's actually starting here at this negative pi over 4. That's the first dot of my 5 dots. Okay, that is what I need you to get figured out about the phase shift. And then similarly, we have this thing called a vertical shift, which also moves your graph up and down. What if it's not centered at 0, 0? What if it's moved up a little bit like this one? And so the equation here is written a little bit in a weird way. They have the constant here in front and then negative 2 cosine 3x. So you can also manipulate that. You can move this positive 3 to the end of the equation so it looks more like the parabola that we learned in Algebra 2. You'll see it in both ways, so just be able to recognize that the 3 could be written very in front, or it could be all the way at the end. And so remember, just to recap some stuff that we've learned already, we are combining with shifting up, down, left, and right. So you could also write this equation this way. And remember, this negative 2 means that it has an amplitude of 2, and the negative means it's upside down. The fancy way of saying that is reflected. This 3 that's with the x changes your period, and remember the formula to figure that out is 2 pi over the b value, and the b value here is 3. And this plus 3 shifts our graph up 3. So you can see this is the normal cosine graph centered down here at 0, and if I move every single value up 3, it actually goes back and forth, back and forth, back and forth, but it's up 3. Okay, so all of that stuff is the introduction to how we're going to graph some new things today. So just so you have like step-by-step instructions, I guess, on how to do this madness of graphing with all of these shifts and stuff, I have some kind of steps for you to kind of keep in mind here. The very first thing that you're going to do when you have a phase shift, so just remember, like this very first example, this means right pi over 3. That means that my very first dot is going to be at pi over 3. So we're used to doing this starting at 0, but in the case of having a phase shift where you start your graph left or right a little bit, that's your very first dot that you're going to do. So the first tick mark isn't at 0 if there's a phase shift. Obviously, if there's not a phase shift, like all the examples we have done up until this point, then you just start at 0. But you start at either the left or the right phase shift. Remember that since this is minus pi over 3, since it's inside the parentheses, that actually indicates a phase shift of right pi over 3. From then, what we're going to do is figure out our period. So there is just a 1 in front of this x right here. So my period is normal. It's 2 pi. It's 2 pi over 1. That's the formula that we use for period. So it's just regular 2 pi. And all the other tick marks means you take your period, which in this case is just 2 pi, and divide by 4. So I have done that here. The period is just 2 pi because the b value is just 1. 2 pi over 1 is 2 pi. And then to figure out what all of your tick marks are, again, you have 4 gaps in between your 5 tick marks. So you just take your period, whatever that is, and divide by 4. And yeah, that reduces. So I have each of my tick marks is worth pi over 2. So here's how I'm going to label my x-axis. My very first dot is already there at pi over 3, and I need to add pi over 2 each time to get my other tick marks. And so now is where you need to be a little bit decent at fractions. So I'm going to change that to pi over 2, or add pi over 2 to that. Common denominator for those is both going to be 6. You'll eventually get to the point where you can do a lot of these fractions in your head, which is awesome. But this is going to be 2 pi over 6 plus 3 pi over 6, which makes my next tick mark at 5 pi over 6. So again, I'm going to add pi over 2 to that. And that's the same thing as adding 3 pi over 6, which means my next value is 8 pi over 6. And I'm going to keep adding pi over 2. That gives me 11 pi over 6, and I'm going to do it one more time. I know it looks really messy. You do not have to write the plus pi over 2 in your work on your graph if it's making it really like overwhelming to you or whatever. That is okay. But while we're learning how to do this in our notes, I just want you to be able to look and see and tell how it was that you got all those x values, okay? So basically all I did is added pi over 2 every single time, and a pi over 2 is the same thing as 3 pi over 6, so that they were all common denominators. So again, you can reduce these if you want to. You do not have to. How does the period come into play here? Remember that that's the distance from start to finish. And so if you would subtract your finishing tick mark, 14 pi over 6, minus your pi over 3, your very first one, 2 pi over 6, you get 12 pi over 6, which is 2 pi. The distance between here and here is 2 pi. Anyways, now I have all my x-axis labeled. That is the hard part. Do you remember what the y values are for sine? Like, where do I put all my dots now? So the y values for sine, I'm going to write that down here. Y values for sine are 0, 1, 0, negative 1, 0. That's from the very first page of your packet. And I do not have anything to change in terms of the amplitude. The amplitude is just 1, so I don't need to multiply those to make them more humpy. And I also don't have a number out here adding or subtracting, which would be shifting my graph up or down. So I don't have to worry about any of that in this equation. Now I can just label, this is 1. This is negative 1. Remember, your first dot does not go on 0 because we shifted everything to the right pi over 3. So your first dot x value is at pi over 3. So pi over 3 comma 0, that is from here. At 5 pi over 6, my y value is 1, so I'm going to put a dot there. And then it continues the pattern. And this is what my final sine graph looks like. Why is it shifted to the right a little bit? Because it is right pi over 3. And so I kind of forgot to go back up and re-look at what I had written up here, but after I figured out all my tick marks, I just added pi over 2 every single time. That was labeling my x-axis. And then where to figure out how to put these dots on the graph is using my key points for sine, because this is a sine equation, and with the amplitude was just 1, that means I multiplied all these values by 1, which didn't do anything, and the vertical shift, I didn't have to add or subtract anything because there was no number out here adding or subtracting, therefore shifting my graph up or down. Let's do one more, and then I'll save the rest of them for class to give you guys a chance to ask a bunch of questions and watch me do a couple of them together. So this very first thing right here, this means left pi over 4. So that means my very first tick mark, I'm going to extend this a little bit, is actually over here at negative pi over 4. So I'm not going to put my first dot on 0 because there is a phase shift here. Next thing I'm going to do is figure out the period. Again, there's just a 1 here in front of this x, so my period is just regular old 2 pi. That means from start to finish, the distance between the first dot and the 5th dot is 2 pi. To find my tick marks, I'm doing 2 pi over 4, which is just pi over 2. So I am going to add pi over 2 every single time. So plus pi over 2 puts me at regular pi over 4. How did I do that so fast in my head? Negative pi over 4 plus 2 pi over 4 if you get a common denominator. You'll get really fast at this, I promise. Puts me at positive pi over 4. Now I'm going to add again another pi over 2, which is the same as 2 pi over 4, and that gives you 3 pi over 4. And I'm going to add again another 2 pi over 4, and it gives you 5 pi over 4. So I have 1, 2, 3, 4. I need one more tick mark because you're supposed to have 5 because we have 5 dots. So I'm adding pi over 2, which is the same thing as 2 pi over 4 one more time, which gives me 7 pi over 4. How does the period come into play here? Just a way to check your work to make sure your x-axis is labeled appropriately is that, remember, the distance from here to here is supposed to be 2 pi. So if you do 7 pi over 4 minus negative pi over 4, it gives you 8 pi over 4, which is 2 pi. The distance between here and here is 2 pi. That is a way to just check to make sure you've labeled your axis correctly. Okay, so hard part is done. Now I just need to figure out where do I put my y values. Do you remember the 5 special points or key points for cosine? So the y values for cosine are 1, 0, -1, 0, 1. That's from the very first page of your packet. Those are the quadrantal angles. That is the unit circle. And did you notice that we have a amplitude thing here? Amplitude equals 3. That means it's a little bit more humpy than usual. That means that all my y values get multiplied by 3. So what I'm going to use instead of the 1, 0, -1, 0, 1, I'm going to multiply all those by 3. It's like distributing the 3 in. And that's where I put all my y values. There is no vertical shift. There's no number out here adding or subtracting to anything. If there was, I would do that to all of these y values, but there's not. We'll save that for class tomorrow. And so what I need to do is I need to label my y-axis here. 1, 2, 3, 1, 2, 3. Because that 3 makes my cosine graph a little bit more humpy. So remember, my first dot doesn't go on 0 because of the phase shift. My first dot is going to go with negative pi over 4. So negative pi over 4 comma 3 is my very first dot. So right up here. At my next x value, which is pi over 4, the value is 0. So I'm putting a 0 there. At 3 pi over 4, my middle one, I'm all the way down at -3. And you can see the pattern is going to continue to make the cosine shape. And so here's what that one looks like. Okay. You guys are crushing it so far. Really proud of all your hard work and sticking with it. This is kind of a tough chapter. There's a lot of things to remember. However, there's step-by-step processes that you can follow, which is good for a lot of you guys that want to know, what do I do first? What do I do second? And the other good news is the more you practice this, the more you'll understand and the faster you will be at thinking through all the steps. So save your questions for class tomorrow. We're going to do a ton more practice. You guys are doing a great job. Thanks for watching. I'll see you tomorrow.